Looking at the diagram, you can see the Kalahari high pressure over the interior of South Africa. Now, notice the arrows pointing downwards. This shows subsiding air, which means air is sinking down. As this air sinks, it becomes compressed and warmer, and this creates a temperature inversion. In winter, the base of the inversion layer is very low, almost at the level of the plateau and below the escapement. This inversion layer acts like a lid. Because of this lid, moist air from the ocean cannot rise. It cannot cross the escapement. It cannot reach the interior of the plateau. So even though there is moisture near the coast, it is blocked. As a result, the interior of South Africa is dry. Very little rain falls in winter. Now let's look at the sky conditions. Because the air is stable and sinking, there are clear skies. Very few clouds form. During the day, the sun hits the land. Days are often warm. At night, there are no clouds to trap the heat. Heat escapes back into the space. Night becomes very cold. So winter is characterized by dry conditions, clear and sunny skies, warm days and cold nights. Let's now look at the summer condition on this diagram. First, notice the land surface over the interior of South Africa. In summer, the sun is very strong, so the land is heated intensively. Because the land is hot, the air above it becomes warm and light, and it begins to rise. As the warm air rises, a surface low pressure develops over the interior. Now look at the Kalahari high pressure above the surface. In summer, the air from the Kalahari high pressure is still subsiding, but it does not sink all the way down into the ground. This is very important because the surface air is rising and the subsiding air stops higher up in the atmosphere. As a result, the temperature inversion layer is much higher, and you can see on the diagram that it is above the level of the escapement. Since the inversion layer is higher, it no longer acts like a lid over the plateau. Most of the air from the Indian Ocean can move inland. The air can rise over the escapement and reach the plateau. Now, look at what happens to this moist air. As the moist air rises, it cools. Convectional rain falls. This is why the interior of South Africa is wetter in summer. Thunderstorms are common. Rain often falls in the afternoon.